confirm that p of x equals 5x to the third plus 7, and q of x, the cubed root of the quantity x plus 7 divided by 5, are inverses of each other. When you are confirming or verifying that functions and equations are inverses of each other, you have to look at both of their compositions. So we want to compose p of q of x and see if we end up with x. We also want to compose q of p of x and see if our answer is x. If both compositions are equivalent to x, the equations, the functions, are inverses of each other. So we're going to start by calculating p of q of x. So again, we start with our innermost function q of x and see how it's defined. This now becomes the input for p of x. We're going to have to put this into our function for p. We're going to put that into the function for p. So we're substituting that in. So again, once we put that in for our function for p, we want to start simplifying according to order of operations, and we have some exponents here. We are cubing a cubed root. Remember, cubing a cubed root, squaring a square root, they undo each other, and you're left with just what you had for the input. So we have 5 times our quantity x plus 7 divided by 5 plus 7. We have some multiplication that we need to do. So again, since this is written as a fraction, I wrote the 5 as a fraction. And we can multiply across and simplify. And so once we multiply across, we can see we've got 5x divided by 5. Well, that's going to be x. 35 divided by 5, that's 7. And we have the 7 from the original function. So we have two like terms here again, 7 and 7. So we're going to end up with x plus 14. Well, we can see that this composition did not end up being x, so we can say that they are not inverses of each other. If you wanted to try the other composition first, q of p of x, you'd have gone through the same process. Let's take a look at that composition. So again, here we're starting with p of x, and that becomes our input for q of x. And we would perform our operation. So for this one here, we'd have to do some simplifying in our numerator. So we'd have 5x to the third plus 14 divided by 5. And then we could look at the fractions and pieces and try simplifying those. So we'd have 5x to the third divided by 5 and 14 divided by 5. Well, 5x to the third divided by 5, that would be x to the third. 14 divided by 5, I can't simplify that. I really can't do anything else to simplify my cubed root because it's the cube root of this entire quantity. We can't undo that. So again, this is our composition. It's not equal to x, therefore the functions are not inverses. So in this case, again, we look at both compositions. If one does not equal to x, you could stop and say that they're not inverses. It doesn't matter which composition you do first. If you do get one equal to x, you should try the second one and confirm that that equals x. Again, if both compositions equal x, they are inverses. In this case, they are not.